I think Dr. Amarnath Banerjee has joined.
Yes, ma'am.
Yes, good afternoon, Mangan.
Good afternoon, sir. How are you?
Fine.
Sir, have you checked all your sound and I mean the
I
screen,
think
everything
it's
is clear?
okay. I'm talking to you. It's
Yes, I
okay.
can listen clearly.
Uh, there's no echo or other things.
Yes, and your presentation is okay?
Yeah, presentation is okay.
Okay.
I've tested it. No problems.
Okay, sir. Okay. Okay, sir. We are just about to start.
Mhm. Let me know. I'll start it.
Yes. I think principal sir has joined. Okay. Am I clearly audible and visible, Gautam sir?
Yes, ma'am.
So, welcome back and good afternoon, dear audience. Now, we are going to start our next technical session, and this technical session is basically based on the emerging trends in electrical engineering. And the first speaker, that is the keynote speaker of this session, is a very old acquaintances, one of my very old acquaintances, you can say. And even I can remember that I started my college teaching just when I was there. I was under the administration of Sir. Sir was the principal of that very engineering college. So it is a quite a long acquaintance, you can say. I am really fortunate that still I am quite able to maintain a good relation with the Professor Dr. Ambarnath Banerjee. Now let's take this opportunity to formally introduce Professor Ambarnath Banerjee in front of you. So Professor Dr. Ambarnath Banerjee received the BE degree in electrical engineering from the University of Roorkee and the ME from University of Rajasthan Jaipur and PhD from Jadavpur University Kolkata. He joined Instrumentation Limited, Kota, India in 1978, and he has 22 years of experience in research and development of control and instrumentation systems of various process industries such as power plants, steel industries, and chemical plants. Also, he has around 2 years of experience in erection and commissioning of control and instrumentation systems. He voluntarily retired as Deputy General Manager and joined teaching in 2002. He was the principal of Kingston Polytechnic College at Barashat, West Bengal till 2008. Then he joined Meghnad Shah Institute of Technology, Kolkata as professor and head of the Department of Electrical Engineering. It was from 2008 to 2019. He was the academic chairman at Kingston Educational Institute in the year 2019 to 2021. He joined Electrical Engineering Department at Narula Institute of Technology as professor in the year 2021. He has around 45 papers published in IEEE Transactions, international journals, and in various other conferences. And his fields of interest include power electronics, power systems, power quality, static wire compensation, and process control instrumentation. Presently, Sir is the senior member of IEEE USA and life member of the Institute of Engineers. So we are really fortunate to have Professor Dr. Ambarnath Banerjee on this platform. So I would invite Sir to start his presentation. Sir, please.
Thank you, Moa madam. Let me start first start the presentation and then talk about it. So let's start.
Yes, sir.
Uh, Good afternoon, Dr. Subhashish Banerjee. Good afternoon, Professor E.K. Kormokar. Good afternoon, Dr. A.K. Sharma. And good afternoon, Professor Mahua Datta. She has just introduced me. And good afternoon, Professor Gautam Das. Good afternoon, all the faculty members who are present here. And good afternoon, all my dear students. I think I am audible now, correctly, Mahua?
Yes, sir. Yes, sir.
Thank you all for giving me this opportunity for presenting my paper, Emerging Trends in Power Generation and Utilization. Of course, it is not a paper, it's just a lecture. And in your national seminar on development of engineering education and practice, TEEP 2022. Thank you all. This is the content of my lecture, and my aim is to take you on a tour of the way the generation of electricity has taken from the past to the present day, and also to see how the utilization, that is the load, has changed from year to year to the present day. Electricity is very important. Why I say important? Because the per capita income of a particular country, it depends on how much of electricity an individual of a country consumes. There's a direct relation between the consumption of electricity and per capita income. You can see the consumption of electricity in America and the consumption of electricity in India. There's a vast difference, and so is the difference of per capita income and an individual's income per year. So that it is, electricity is very important, and how it has evolved, we'll see. Early generations were near the energy centers, where the mechanical energies are available, and from there the electricity were generated. Edison started his journey of electricity generation in England, and Westinghouse started it in America. And Westinghouse efforts were on the banks of Niagara Falls. Now, the banks of the Niagara Falls, there is limited land, paucity of land was there, and in the early days, when there was no transformers and other things, so generation and utilization were made in close proximity. Close by the utilization was done close to the generators. So the manufacturers, they moved into the banks of the Niagara Falls, and there was really a tough fight for getting land for generation of electricity. So this thing got a little bit of reprieve when Westinghouse came out or invented the transformer. The winning combination was to generate electricity on the scarce land and close to the source of energy, and then distribute that energy to the place where it could be put to better use. Like you move inland and have your industrial parks where you can have the productions, the factories, and the electricity could be taken to the cities where there was large scale requirement of electricity. Then came the concept of economics of scale. That means smaller generations were costing uh, more, and the cost of electricity per unit was becoming more. So they started thinking in terms of bigger and bigger size of generation. So uh, in my life, I have seen generators of 30 megawatt. That was the smallest generator that I had seen, and that was probably at Indraprasth in Delhi. That was phased out uh, quite fast. Earlier generators were in kilowatts. When I joined my when I joined the industry, then BHEL, it was manufacturing 200 megawatt generators, 210 megawatt generators. So that was the size that was there at that time. Then came NTPC. Government started this NTPC with an intention to put up super thermal power stations, STPS. And STPS where each thermal power station were supposed to produce around 1000 megawatt or more. Our Farakka is Farakka thermal power station is an STPS. Then BHEL started with the coming up of STPS. BHEL started thinking of 500 megawatt generators, 500 megawatt size generators. By 2000, the government started thinking of further bigger uh, power stations, and that was called Ultra Mega Power Projects, UMPP. So that was 4,000 megawatt power stations. Then came the concept of distributed generation. Global warming, pollution, all this become the talk of the day. People all over the world started talking about it because the uh, water level of the level of the sea was increasing, the frequency of cyclones were increasing, the ozone layer was getting disturbed. So people started thinking about something which will not pollute the atmosphere. And secondly, there was depletion of the stock of fossil fuel. Fossil fuel was not unlimited. Fossil fuel was limited and concentrated with a few countries. And recently we saw the reason of that, because of this concentration, that we saw the crude oil price uh, flaring up, and it's almost doubled, and we are suffering from that since India do not have a crude reserve quite good, or almost we do not have any fossil fuel reserve. Uh, we have coal reserves, but we do not have crude oil reserve. So that is where we are suffering. So all this led to thinking about using renewable energy resources, what we call RES. There are many resources which can be used and which gets renewed in the nature. So mainly the things that is widely harnessed are wind, mini hydro, and solar energy. Hydro was there from the very beginning, but mini hydro was not there. Mini hydro means like the run-of-the-river power plant, a small waterfall, and you put up a hydropower plant there. Wind and mini hydro, micro hydro, they for harnessing them, the technology of ACIG and DFIG, self-excited induction generator and doubly fed induction generator, they came into being. They, instead of using the normal synchronous generators, self-excited induction generators and doubly fed induction generators were used for wind and mini hydro. Solar energy, there were two types of solar energy harnessing that was done. One is the solar thermal, another is called the solar PV. Solar thermal is direct conversion of solar energy, solar light to thermal, that is, for example, solar cooker, solar water heater, and light. Solar PV is using the photovoltaic resource to convert the photons of the solar power, solar light into electricity. This renewable energy resource generation got a fillip because of the development in power electronics, custom power devices, and packs. They came up quite rapidly in the last 20, 30 years. And because of that, this renewable energy resources, they got quite an impetus. Large RES-based power parks were created in the vast expanse land that was available, like the desert in the Rajasthan, the wasteland of Kutch. So all that places, your wind energies were put up, sometimes solar energy, big parts were put up. Then large number of small RES were also put up by individuals in the cities, like the rooftop solar. That led to the concept of distributed energy resources, DER. These distributed energy resources, they were connected to the, directly they fed the local load, or they were connected to the distribution system. And this led to the concept of distributed generation. Like this, it is a distributed generation, DER. Distributed generation output can be an AC or a DC. So accordingly, the interface has to be an AC to DC converter or DC to DC converter. Then there is a DC bus, which has a battery, a storage to maintain the DC bus. And this DC is then converted into AC of the desired frequency, 50 Hertz in our case, and connected to the three-phase distribution system or a single-phase distribution system. And this distributed generation got further fillip when United Nations Framework Convention on Climate Change, they declared that fossil fuel will not be used after a certain date. I think in case of India, it is India decided 2025. So people started widely using distributed generation. What is the present scenario? So present scenario is centralized power generation with fossil fuel and some bulk generation of renewable energy resources with renewable energy resources, and these are connected directly to the grid. So this is state, one state of affair that is going on, and the other is small RES based generations being connected directly to the distribution system. Now the problem came up that uh, our system, older regulatory system, that did not allow, of the power system, definitely, that did not allow individuals to generate electricity, and they required, a requirement was there to that permission has to be sought from somebody, probably at Delhi Central Electricity Authority, for doing any uh, generation. So there was a need to do restructuring of the regulations of the power system. So in Indian Electricity Act came up in the year 2003, Indian Electricity Act 2003. Of course, after that, a lot of changes has taken place, and lately, I think uh, last year or beginning of this year, I think there was an act in Delhi um, by the parliament, and that has created quite a uproar in the parliament. All those things are there. On the load front, also a lot of power system polluting load came up, like the arc furnace, the SMPAs, the large motors, and all these things, they were polluting the atmosphere. And pollution of the atmosphere means, yeah, not the atmosphere, but the atmosphere of the power system. So polluting the power system means you will have harmonics, you will have depths, you will have uh, mm, unbalances in the power system, and all these things are harmful for certain critical loads, or uh, we can say they are sensitive loads. So uh, three custom power devices they came up: DVR, DSTATCOM, and UPQC. DVR is used to uh, when the source voltage, when the source voltage is distorted or polluted, then DVR can be used in series to produce a unpolluted uh, power, unpolluted voltage. And if the load is polluted, then DSTATCOM is connected in sun, so that the pollution from the load do not corrupt the power system upstream, and so that other power systems connect, other loads connected to the power system, they don't get affected by this polluting uh, load. So, and UPQC is a combination of DVR and DSTAT. So all these things, all these things, they led to the evolution of microgrid, because what the people started having small uh, RES generation, they thought that why not get the benefit of the grid when we are generating? Why not get all our generations connected together and form a small grid, so that we can have the benefit of the grid? So this is the microgrid. It is connected by a static switch to the utility grid. The RES-based generation, local electric power storage, and local loads all act as a single entity and is presented to the utility. It is connected to the distribution system by a static switch, and whenever there is a problem on the utility grid, whenever there is a disturbance on the utility grid, the static switch opens, and the microgrid works as an islanded system and provides power to its own local load. The power quality to the sensitive loads is maintained by the microgrid. This is the structure of a microgrid. That is, a few sensitive load provided by local generation and some non-sensitive load directly connected to the grid, and there is a static switch to isolate the two portions. So whenever there is a disturbance on the grid, then the static switch opens and the non-sensitive load can get power directly from the grid, and the sensitive load, it being islanded, it continues to get unpolluted uh, and good power quality power to the sensitive loads, so that the sensitive loads, their production is not disturbed. Now the microgrid can be an AC microgrid, can be a DC microgrid, can be a hybrid of AC and DC. So this AC and DC microgrid, because uh, in spite of our most loads, our supply being AC, many of our loads, like the LED lamps, they can take directly DC power. And some of our generations, like the solar PV, that is a DC generation. So why not have a DC microgrid? So DC microgrid also came into being, and sometimes hybrid microgrid, an inverter is placed in between, and on one side it is AC, and on the other side it is DC, and each side is providing its own load and having its own generation, and there can be an exchange of power between the AC and the DC microgrid. Then came the concept of generation, how the generation should be controlled. Previously, we have seen in our country also that there was a centralized generation, a fixed generation, and when the load became more than the generation, then a certain amount of part of the load were shut down. That means what we call the blackout. So there was a load shutdown to schedule shutdown at different places, and the generation and load parity was maintained. Now, that was because at that time, to start a unit, it took around 10 to 12 hours to start a unit, a thermal unit. But with the concept of renewable energies, it can be started very fast. So people started thinking about why not make the generation following the load. Whenever the load increases, the generation must increase. Whenever the load decreases, the generation must decrease. Now, the concept of load flow, generation following the load is being used now in certain cold countries. A large portion of the load is heat load. That means heating of the rooms, heating of the factories is an important part of the load. So importance was given to the generation, which whether it should follow the heat load, whether it should follow the electrical load, or it should follow a mixture of the two, a hybrid load. So this is a microgrid, which is a with a CHP operator. The boiler is there. A micro turbine is producing electricity. The micro turbine exhaust is used for heating, used by the heating system to produce a steady heat supply to the user. The micro turbine again also supplies the electricity to the user. The user can exchange the electricity with the grid. In case the the micro turbine is not able to provide enough heat, the boiler steps in and produces steam, and that steam is again used for heating. So this is one of the concepts for that is called combined heat and power operating system. Then came the concept of prosumers, producers plus consumers. They started thinking of generating profit from whatever the system they have put up. Small plant, but they want to generate profit because it's possible to generate profit from that. So they wanted to sell that extra electricity that they had into the distribution system. And for that, whatever they are buying from the grid and whatever they are selling to the grid, the difference has to be calculated. And then came the concept of smart meters, smart net meters, net supply of electricity. So net metering is the concept of metering of electricity that is being done is been implemented at quite some places. This is where this concept is being used. This is a microgrid connected to a grid. MGO is the microgrid operator, and prosumers are there. The prosumers, they consume both heat and electricity, and they also produce electricity. And CHP is there to produce heat and electricity. The MGO, it decides the cost of heat and electricity that it is going to sell to the prosumers, or it will buy from the prosumer and sell to the grid. So the MGO controls everything on the microgrid. This is a microgrid operator. Then came with this electric power exchange. This came with the Electricity Act of 2003, and now previously what was happening is all the electricity boards, they were generating and they were selling directly to the customers, and getting the dues from the customers was entirely the responsibility of the electricity board. Now these electricity boards were disbanded, and the generation was given to a Genco company, and the distribution company was asked to distribute it to the consumers and collect the cost of the electricity from them. And the distribution company will then regulate or have a contract with the generation company to decide when and how much of power it will buy from the generation company and sell it to the customers. So this was done on the electricity or electrical power exchange. Now, for doing this thing, the size of the electricity, the amount of the electricity, that has to be appreciable, because the cost of doing trading on the exchange has to be compensated by the size of the amount of the electricity, size of the electricity that is being traded there. So prosumers of microgrid felt the need for trading the power generated by them on the exchange to increase their profit. The amount of power the microgrid could offer was usually too small. What happened is the concept of virtual power plant and community microgrid that evolved from this particular need. So what is virtual power? The VPP operator aggregates the flexible power generated by the DERs and provides the energy and auxiliary service to the grid. That means The VPP operator will aggregate all the power need of all the DES, and then it will power need or power excess power by the DER. Then that they will go to the exchange, because the VPP has aggregated them, so it has a large chunk of power requirement, or power cell requirement, buy or sell requirement, either way, and that it can put up on the exchange. So it was just like the concept of dispatching power. Central power stations were able to if it is told that uh, you give so much of power, say 10 megawatts of power at such and such time, the central manufacturing or the central generating plant could do it because it was generating continuously. But in a DER, say the solar PV, so what happens is some the cloud comes in, and it is not sure that the solar PV will be able to generate decided power. So dispatching capacity is not there in case of DES. So participating in power market, this VPP could do it because it will collect it from different DERs, and thereby it was sure to supply that amount of power. So it is called a virtual power plant. It was acting like a virtual power plant. So this is a concept where many wind and solar power solar PV has been connected, and if the solar PV is not able to give the power, the wind can give, and this thereby the virtual power plant was sure of supplying that amount of power that has been decided on the exchange. Then came the concept of community microgrid. Each microgrid maintains its autonomous nature. A DC microgrid, it will maintain its DC nature. A AC microgrid, it can operate at 60 hertz, it can operate at 50 hertz, it can operate at 49.5 hertz. So each microgrid can operate at its own frequency, its own way, its own level. And each level, I mean the voltage level. Each microgrid may obtain their connections to the main utility grid. I will not say may, it will have its connection to the main utility grid. Have an interconnection with the microgrid in the neighborhood. So all microgrids in the neighborhood will be interconnected. Thus, they will provide backup power to one another in case of emergency. So one microgrid, suppose suddenly requires 10 kilowatts of extra power. That will be provided by its neighborhood microgrid. Thus, it will be able to tide over its emergency. So what happens is reduced installed capacity of each microgrid. You have not to each microgrid has not to take care of the increased installed capacity that is needed, or the peak capacity that may come once or twice a while. So it can whenever that happens, it can take the power from the neighborhood and maintain that peak load. So this is a small diagram of community microgrid. The microgrid MC0 to MCN, there are n microgrids. They are controlled by their own microgrid controller, MC1, MC2, MC3, MC0. And these microgrid controllers are then controlled by a community microgrid controller. This is they are monitored and supervised. Microgrid controller, they control the microgrid, but these are supervised by this community microgrid controller. Then microgrid, each microgrid is connected to the grid and its internal community AC bus by uh, in, internal uh, converters, IC1, IC2, IC3. Now, this each microgrid can directly take power from the utility microgrid, or it can utility grid, and it can also send power to the utility grid. And in case its IC fails, then it can go through the community microgrid, community AC mains, and through the MG0, it can get connected to the mains grid bus. So this way, and if there is a requirement of, say, MG1 has some more requirement of power, then MGN may provide that power through the community AC bus. So this is the concept that is coming up, and this is how the power generation is being done nowadays. The same thing is written all over here. Each AC microgrid is coupled to the community bus or the mains grid bus by their respective interlinking converter, and all those things are written here only. The presence of MG0, the community AC mains bus, improves the reliability by providing each microgrid with a backup access to the utility grid in case of unintentional islanding. So that it is, these are the conclusions. A paradigm shift in the way the power is generated and transmitted to the loads from large-scale centralized generation to the small renewable-based generation connected to the distribution system. With the development of the power electronics and enhanced computing, power harnessing and renewable energy resources and generation of the power from them got a further impetus. Accordingly, the grid and the protection systems have become smarter. This is very important because since the amount of load, amount of generation coming into the distribution system, that previously generation was coming from the generators to the transmission lines to the distribution system. Now the generations are directly getting fed into the distribution system. Now this is where the problem starts, because the protection systems are all designed because of with the concept of generation coming from the power coming from the generators to the transmission line and to the distribution system. It has to be modified to take care of the extra power being generated and fed to the distribution system directly. The transmission and distribution losses have got reduced because the generation is being done near the distribution line. The restructured environment of the power systems has benefited both the customer and the producers of electricity. It has brought healthy competitions in the power generation and transmission distribution. Cost per unit is likely to get reduced. It will take time because everything has to mature. This is going to help the development of mankind and in the improvement of economy. Thank you. That's all. That is my presentation.
Thank you so much, sir. Uh, Thank you once again for your wonderful, informative, and interesting presentation. Now, I would like to ask the audience, do you have any question, any one of you? Please raise your hand. Anyone is having any question? Actually, a lot of electrical students I can find right here in the audience. So I really expect some questions from the electrical students actually. Any question from anyone? Okay. Then, sir. Yes, sir.
In case there is no questions at this moment, they can ask me over my phone, and or they can send my email address is there with you. They can send me their queries later on. I
Yes.
will be glad to answer them.
Definitely, definitely, sir. Okay, the students and from the audience, if any question just you want to ask, you may tell me. I can just forward it to sir. Okay, so in sir's mail or sir's phone number is also with me. Okay, sir. Then thank you so much once again, and kindly accept a token of appreciation on behalf of Elite College of Engineering. Kindly accept it, sir.
Okay.
Sir, kindly accept this little token of
Thank you. Thank you.
appreciation.
That's
That is
wonderful. Thank you very much.
okay. Thank you so much, sir.
Thank you.
Okay.
Uh, I'll stop my
Moving forward.
presentation then.
Yes, sir. Definitely. Moving forward to the next segment of this session, that is the presentation of contributory papers. And the first presenter uh, is Professor is Dr. Abhijit Chakraborty, and sir is the head of the Department of Electrical Engineering in Elite College of Engineering. So we can say that sir is our in-house speaker. And the topic of sir's presentation is harmonic separation of AC source current of a single phase source fed induction heating system. So this paper is authored by Dr. Abhijit Chakraborty, and I would request, sir, if he is present right here on this platform, please unmute yourself.
Yes, madam, I am present.
Okay, okay, sir. Okay. Okay, sir. Then you can start your presentation. But before that, I must remind you something that our time is very limited today. So kindly restrain yourself within 10 minutes. Okay, sir. Start. Please start.
Is it visible, madam?
Yes, sir. Slide is visible.
Okay. A very good afternoon, our principal sir, Professor Dr. Sudip Posak sir, our moderators, Professor Moha Datta madam, and Professor Deepushi Sharma madam. A very good afternoon to our honorable judges, Dr. Subhashish Banerjee sir, Dr. A.K. Sharma sir, and Mr. Sujit Prabhupada sir. It is my, am I audible, madam? Am I clearly audible?
Sir, you are clearly audible.
Okay. It's my privilege and honor to give me the opportunity to deliver this presentation on the topic harmonic separation of AC source current of a single phase source fed induction heating system. This is the figure 1 that depicts the basic induction heating system. The basic induction heating system consists of a source. It is actually induction heating system is actually regarded as a contactless heating process, where the heat energy or thermal energy is transferred from the source to the load by contactless process or contactless method. So in an induction heating, it is regarded as a contactless heating process. Earlier told, here we need an AC source. It is an utility frequency AC source, means 50 Hz AC source, which is rectified by into DC from AC to DC by an uncontrolled rectifier. Then it is inverted to high frequency inversion, high frequency AC, and then it is fed to a working load where heat is generated. Induction heating process is very fast heating process where no pollution takes place. It can be either a fixed frequency or variable frequency. Now, during the power generation, during the heat generation of the induction heating process, as it is made of very high frequency power semiconductor devices, and which undergoes a very high frequency switching operations. So due to these high frequency switching operations, certain amount of high frequency noises is always produced. And all these high frequency noises can be categorized into two categories. They are either conducted noise or radiated noise. So up to 30 megahertz, the noise is conducted, and above the 30 megahertz, the noise is considered as the radiated. Now, here the main objective of this paper is, here the induction heating system, the sub-switching techniques I have used is the asymmetrical voltage cancellation technique, by which we can control the output power of the proposed induction heating system. And during this sub-switching techniques, it is regarded as a very high frequency sub-switching techniques, asymmetrical voltage cancellation technique. A very high frequency noises are generated, basically conducted noises, conducted EMI noises. And these high frequency conducted EMI noises propagates from the load to the source. Okay, and this distorts the input AC current, which should be sinusoidal, but due to the presence of these high frequency noises, the input source currents become non-sinusoidal, which is not good for the other apparatus which are feeding from the same common source, AC sources. So all these are also the induction heating system. It will put some adverse effects on the normal performance of the induction heating system. So all these high frequency conducted noises has to be suppressed, and to suppress these high frequency noises, I have to use a ring type passive LC type LC filter. It is basically a low pass filter. So this is the overall circuit diagram of the induction heating system, proposed induction heating system, using the high frequency filter, using the high frequency suppressive filter, that is a low pass filter. We can see that after the AC source current, after the AC source, the filter circuit is used. That is, the filter circuit is used in between the AC source and the rectifier unit. At first, there is the source, AC source, then the filter comes, and after that, it is rectified when an uncontrolled rectifier, and then a full bridge series resonant inverter is used to produce the high frequencies current feeding the load. The proposed filter uses two series inductances. We can see the L are the two series inductance and two parallel capacitance. The inductance has the ability to prevent the high frequency current signal, whereas the capacitance has the ability to provide block the entrance of high frequency voltage signals. Basically, the two capacitance can suppress the differential mode signals. Actually, the high frequency signals can be categorized into two categories: the common mode signal and differential mode signal. The differential mode signal are more predominant than the common mode signal. So these parallel capacitance can block the differential mode signals. And the two inductance can also block the differential mode currents. Already I have mentioned that the proposed fixed frequency controls which are being used in this particular application, that is the asymmetrical voltage cancellation control. This asymmetrical voltage cancellation control is a wonderful and very reliable sub-switching technique that can be used for induction heating system for wide range of power control, and it is equally applicable for low as well as moderate and high frequency applications. And high frequency and low, medium, and high power range also. So it has a greater range of flexibility. This is the output voltage and current waveform that we can get from the induction heating system using the asymmetrical voltage cancellation control. We can see that in asymmetrical voltage cancellation control, the output voltages has a square waveform. Okay, and the basic control parameters are beta, alpha plus, and alpha minus respectively. So all these three parameters can be controlled to control the output power, and the current that is lagging in nature because of the resonant load. The current is such that that we can obtain a ZVS operation, that is the zero voltage switching operation during the turning on of the each power semiconductor device. This is the power equation that we can obtain from this induction system using the LVC control. Here, the output power depends on the V01. So V01 is the fundamental component of the output voltage. Okay, and that depends on the control angle. The V0 is the magnitude of the V01. It depends on the control angle alpha plus, alpha minus, and beta. So by variation alpha plus, alpha minus, and beta, we can control V01 and the output power. Now, the working principle of the proposed low-pass EMI filter, that it can control, it can attenuate, it can suppress both the common mode and differential mode EMI noises. The common mode noises are those noises which flows from the source to the load, from the line and the neutral terminal in the same direction. Whereas in the differential mode noises are those noises, high frequency noises, which flows from source to the load through both line terminal and the neutral terminal, but in opposite direction. So here differential mode noise are more predominant than the common mode noises. The two inductors I already have mentioned, having a value from 1 microhenry to 200 microhenry are enough to suppress the CM and DM noises in series. And the X capacitors, there are two capacitors, X capacitors, they are parallel capacitors, having the value 0.1 microfarad to 1 microfarad, they are sufficient to suppress the DM noises, the common differential mode. And there are some Y capacitors also, which are not mentioned here, which are not depicted, they are shown here. They are also have the capability to suppress the common mode noise. Since the differential mode noise is not predominant, therefore have to give more emphasis on the more importance to the differential mode noise. Now, resistance R at both ends of the discharge register of the X capacitor. Now, this is the circuit diagram of the ring filter, and the equation 5 is representing the overall reactance of the proposed filter, and omega equation 6 is representing the cutoff frequency. For the sake of simplicity, I am taking the value of L as 200 microhenry and the value of capacitance is 0.1 microfarad. So we can get a cutoff frequency of 35.6 kilohertz. That is, it can block all the signals, all the noises above 35.6 kilohertz. Here the switching frequency I have taken as the 40 kilohertz. Okay, so input source current is affected mostly by the signal having the fundamental frequency of 40 kilohertz and above. Okay, and if we look on the, these are all the circuit parameters, it's the filter parameters. So this is the circuit diagram of the proposed induction heater without the filter. Here filtered circuit is not used, and with the simulation we can see that since filter is not used, so input, this is the waveform of the input source current for that particular control angle alpha is equal to 30 degree, where you can see that the source current is not sinusoidal in nature. A very large high amount of high frequency harmonics is superimposed on the input source current, and so the input source current becomes non-sinusoidal in nature. So it will affect the system. So to filter out this, we use the proposed ring type filter. This is actually a line impedance stabilizing network, LISN. The proposed ring filter is actually a line impedance stabilizing network. So this line impedance stabilizing network can suppress the CM and DM noises, and after the simulation, we get the input source current like this. So almost 95% harmonics, both common mode and non-differential mode noises, are suppressed by this using this filter. For this, and we are getting the same input source current waveform with the same control angle alpha is equal to 30. So finally, the conclusion is that the proposed low-pass filter can suppress the high-frequency harmonics level in the input source current satisfactorily. The proposed low-pass filter can improve the power quality of the input source because the input power AC source current remains sinusoidal. So obviously, the power quality of the input source current gets improved, and this filter can suppress both common mode and differential mode noise satisfactorily. Thank you.
you so much, sir. It was
Thank you, Dinesh.
an interesting presentation.
Thank you,
I
madam.
would like to request the audience, okay, please ask the questions. I think sir is ready to answer now. And I would request the web hosts, if I miss someone asking question, please notify me.
Hello.
Yes, sir.
Uh, uh, Hello. Have you used any simulation software for the output, the result?
I have used PSIM simulation software,
Okay.
power simulator.
Power simulation software. Okay.
I would request our another honorable judge, Dr. Ashwini Sharma, sir, if you wish to ask any question.
Yeah, okay. Mr. Abhijit, my only
sir.
question is that what is the application of your this harmonic suppression? And is it improving upon the efficiency, or what is it doing with the heating system?
Obviously, it's actually it can improve the design of the line impedance stabilizing network. If line impedance stabilizing network gets improvement in its design, then obviously the efficiency will be improved, the power quality of the line will be improved. The other apparatus which are feeding from the same line, they will not be affected so much.
Yeah, that's right. So will it be improving upon the maintenance, or it will be improving upon the heating?
No, sir. It does not have any impact on the heating. Heating process is totally separate. Actually, it protects the entire induction heating system. If you improve the design of
Right.
the
So you have worked on the safety aspects of it.
obviously safety aspect. In terms of
Okay,
safety aspects,
thank you.
it will have a remarkable effect.
Dr. Shubhashish Banerjee, though sir is a session chair, but I know that sir is also from the electrical department. Okay, sir, would you like to ask any question?
Professor Chakraborty, I'd just like to ask you one thing.
Yes, sir.
That the economic part is how it has been considered. Economics of this sort of system.
It does not have a direct impact on the economical aspect, but if it requires less maintenance, if power quality gets improved, then in that aspect we can say that it is economical. But it does not have any direct economical impact on the.
It does not have a direct economical impact, but your maintenance
Indirect,
and other things are easy, isn't it?
Yes, sir. Yes, sir.
Okay, thank you, Professor Chakraborty.
Okay, sir. Thank you, sir. Welcome, sir.
Okay, audience, do you have any question? I think a lot of electrical students and teachers are there. Do you have any question to sir? Dr. Chakraborty? Do you have any question, anyone from the audience? Okay.
I have one question.
Yes.
Yes, please.
Yeah, sir, if you can explain what is the effect on the stability of the system, it will be good.
As the system
Power
gets
system stability.
with respect to power system stability, if the high frequency noises are filtered out, then obviously the system remains stable, the power continuity is maintained.
Harmonics will not be there, right?
Harmonics, the power input source, the main source is not affected by the high harmonics. So obviously power quality is maintained. So that is the most beneficial aspect.
Quality of power is maintained. Okay. Fine. Thank you, sir.
So actually the nonlinearity behavior of the induction heating system gets suppressed. High frequency generation means the induction heating system is behaving non-linear in nature. So whenever the high frequency noises are suppressed, it's behaving in linear mode.
Okay.
We are linearize the whole system.
Okay.
And the
fine.
load, the impedance of the system looking by the load towards the source. If we're looking back, the impedance of the system of the source with respect to the load, that impedance gets stabilized. That's the main fact.
Okay. Thank you, sir. Thank you.
Okay.
Okay, thank you so much. If I'm not missing, I don't think any more question is there. So thank you so much, Dr. Abhijit Chakraborty, once again for your wonderful presentation, and you have patiently answered all your questions. Okay, thank you so much.
Well, thank you.
I'm going to the next presentation, and once again, this is another in-house speaker. So the next topic for presentation is comparative study in different structures of microstrip patch antenna design. And the author is Bonani Ghosh from Elite Institute of Engineering and Management. If ma'am is present right here, I would request ma'am to please unmute. And let me just tell about the session chair and the session judges of this session. The session judges are Dr. Ashwini Kumar Sharma and Professor Abhijit Karmakar, and the session chair is Dr. Shubhashish Banerjee. Bonani Ghosh, ma'am.
Yes, ma'am.
Okay, ma'am.
Just a minute, ma'am. चलेगा? Thank you, ma'am, giving me this opportunity. Thanks to DEEP 22 organizing committee. Good afternoon to all respected delegates, respected judge, directors, and principal sir, all respected HOD sir, ma'am, and faculty members, and my beloved students. Myself, Bonani Ghosh, Assistant Professor and Head, Department of Electronics and Telecommunication Engineering from Elite Institute of Engineering and Management. Today, my paper presentation topic is the comparative study in different structures of microstrip antenna design. For antenna design, impedance matching is an important factor. So I hear my presentation, the comparison between different structures, hexagonal and square patch antenna, and compare their performance at same value. The proposed antennas are selected as ultra-wideband self-complementary monopole antennas. I represent here the comparative study of microstrip square and hexagonal patch antenna and their characteristics like radiation pattern, VSWR versus frequency, S parameter versus frequency, impedance versus frequency, current density, etc. Here, I represent the design of two different structures. Figure 1 represents hexagonal structure for 2 elements, and figure 2 represents square patch structure for 2 elements. Now, what is self-complementary? The complementary structure of antenna is identical with its original structure. UWB means ultra wideband, which is very low energy level for short range and high bandwidth of the radio spectrum. All we know, ultra wideband technology put more importance on small printed antennas because fabrication procedure is very simple and it can be easily integrated with other components on the same PCB. According to surveying of many research papers, I have analyzed here different matching techniques by simulation. So, I want to go to my presentation design factor. Here is the two figure, hexagonal structure and square structure. And here is the resulting table. Here I have put, in case of both structure, at same value, and I want to compare their performance at same value. Here I use the substrate or dielectric as FR4, which is easily available in market. And the different characteristic curves of my proposed antennas after simulation, that is VSWR versus frequency for hexagonal structure and square structure. Here, VSWR for hexagonal structure is between wide bandwidth 2.8 to 9.4 gigahertz. Okay, and in case of bandstop frequency, here the 3.3 to 5 gigahertz and 7 to 9 gigahertz, which is allocated for wireless LAN, hyper LAN technologies, and square patch antenna consists ultra wideband range but less than hexagonal structure. Here I represent the S parameters, S11 versus frequency. Look at the picture here. S11 is at 30 dB in case of hexagonal structure at 4 gigahertz. But in case of square structure, it is below 20 dB, very less than hexagonal structure. And the frequency range is at 3.45 gigahertz. In case of S parameter S12 versus frequency, S12 for case of hexagonal structure is below 30 dB, and in case of square structure, it is very poor. And the radiation pattern, in case of radiation pattern for hexagonal structure, the figure 9 and 10 represents hexagonal structure at phi equal to 0 degree and phi equal to 90 degree, which shows the omnidirectional nature. But radiation pattern in case of square structure, figure 11 is shown the square structure, which provides high gain but less than hexagonal structure. Figure 12 and 13 represents the Smith chart of hexagonal structure and square structure. Radiation Smith chart of square structure obtained low impedance than hexagonal structure, shows low impedance than hexagonal structure. The resonating frequency is 4 gigahertz, which is working within microwave band, that is C band. Now come to the figure 16 and 17. Figure 16 represents current density of hexagonal structure. Look at the picture. Here, surface current density is highly concentrated in case of hexagonal structure in one part, but in another part, it is very less concentrated in end corner of the another part, and this is the feed line, and it is less concentrated in feed line in case of hexagonal structure. In case of surface current density, in case of square patch, it is highly concentrated in another part, in one part, and in another part it is very poor concentrated in top corner of the patch and in the feed line in case of square patch. Now, conclusion is, since we already know impedance matching is very much important factor in case of antenna design. So here, according to simulation result, we get hexagonal patch antenna is give better result than square patch antenna in impedance matching, better gain, and enhancement of radiation. The speed of response for ultra wideband is very high than in case of hexagonal patch than square patch. So, if we use hexagonal patch antenna, hexagonal structure for 2 elements, we get better impedance matching, better gain, and radiation is very good, will be very good. And the application for this structure, we can use this in case of tumor detection and wireless communication, etc., where ultra wideband required. I am very much grateful to Professor Dr. Manojit Mitra, ENT, IIST Shibpur, for his unlimited guidance and lab support from Mr. Manush Midda. Here are the references which helped me for ready my paper, and thank you.
Thank you, ma'am. Thank you, ma'am. Thank you, ma'am, for your wonderful presentation. I would like to request the audience, if you have any question, you may please unmute yourself or you may raise your hand.
Madam, what are the
Yes,
different?
sir. Yes,
Madam, what are the different? Am I audible, ma'am?
yes, sir.
Okay.
Yes, sir.
Madam, what are the different type of economical comparison for different type of structure you used for the different patch? Economical comparison and
Economical difference, sir. Okay, sir. Actually, if we use FR4 sheet, actually in market there are various sheet which are all of which are not available in market, but FR4 is very easily available in market, which I use here. And in case of hexagonal structure, it is if we use the FR4 sheet, I think it is not very cost than square patch, but performance is very good than square patch, sir. But if we use, I think I have here shown the reference is Castorleaf complementary structure. You have seen there, sir. Quasi self-complementary structure, castor leaf. In case of castor leaf, if we use FR4 sheet, but the for mechanism, the castor leaf structure, it will be costly than hexagonal structure. So we can easily use hexagonal structure and square structure, and but there are no much difference between hexagonal structure and square structure for economically, sir.
Okay.
Okay, thank you so much, sir. Do you anyone's are there any question? Any other person? Any other one from audience? Or I would request our another session judge, Dr. Ashwini Kumar Sharma, if sir likes to ask any question.
Well, I think I'm fine. I'm fine.
Okay, sir. Okay, sir.
Thank you, sir.
Anyone's there? Gautam sir, am I missing someone? Has anyone raised the hand?
No, ma'am.
Okay, okay. Okay, it is very unfortunate that a lot of electrical students are present here, but they are not asking any question. Anyway, ma'am is always there in the campus. So if you have any question, you may ask her at any point of time.
Okay,
Okay,
sure.
thank you so much, ma'am.
Sure, thank you, ma'am.
Okay, so I'm going to the next presentation. The next title of the paper is Development of Zero Energy Consumption Building, an Approach Towards Green Campus by Professor Utpal Goswami. Okay, I would request the web host, please mute Bonani ma'am.
Yes, yes, ma'am.
Okay. Okay, our next presenter is Professor Utpal Goswami. If sir is present on this platform, I would request the web host to unmute him. I think Professor Utpal Goswami is not present right here, right now. Okay, then this paper. Yes, sir.
Yeah, I should tell that Professor Upal Goswami, if present, please raise your
Is pre-
hand.
Okay, okay. Please, then please unmute him.
No, if he is present, I cannot find him.
Okay, he is not present. Okay. Then we'll be going to the next presentation. The next presenter, I guess, Shayantan Bose. He is one of our student. It is a student paper, and the topic is WSN-based forest fire detection system. And the paper has some other authors. I think Deeposhree Saha is the corresponding author. She is the corresponding author. Then Vinit Kumar Shaw, Shayantan Bose, and then Shaumendranath Paik. I would request Shayantan Bose, if you are there, please unmute yourself.
Yes, ma'am. Am I audible?
Yes, you are audible.
Can I share my presentation?
Yes, you can share, but please understand the time constraint. Okay, please keep your
Okay.
presentation within 10 minutes.
Okay. Good afternoon, everyone. My name is Shayantan Bose. I am pursuing BTech in Electrical from Elite College of Engineering. Today, the topic of our presentation is all about wireless sensor network based forest fire detection system. These are the content: abstract, introduction, research aim, fire detection and decision making, sensor network for fire detection, confusion.
Shayantan, can you speak a bit louder?
Okay. Next, abstract. Forest is a significant piece of the worldwide biological, ecological, and sporting framework. Forest fire is one of the most natural hazard in all over world. It absorbs atmospheric carbon and filling down soil erosion. An advanced technology, the wireless sensor network, which can work as a fire detection system. Next slide. Introduction. Forest fire has suddenly and unexpectedly spread over a large area. It's nearly impossible to stop that. Because of this, we are lost very large amount of lives and property and additional unrectifiable damage to the ecology in the atmosphere. Most significant issues of wood fire control is that woodlands are generally remote, deserted and unfinished areas full of trees, drying wood and living, etc., which structure a completely ignitionable specialist and represent the perfect medium for fire start and furthermore as fuel for later phase of fire. Humans are the main reason to spread out of fire, like barbecue parties and smoking. Fire can also start by natural reasons such as high temperature in a hot summer day or a wrecked glass in as a collective lens focusing the daylight on a little spot for a length of time and hence promoting fire start. When start begins, then the burnable materials may effectively fuel to feed the fire and central spot. The spot then becomes greater and more extensive, and the existing stage of start is normally alluded to as a surface fire stage. This may lead to swallow the bordering trees and the fire develop quickly. Next, research and evolving research interest is to figure out the quick and minimal expense to make a network through a disseminated wireless sensors arbitrarily spread in woods to make an automatic program, self-coordinate, and a robust network between the sensor to cover a bigger region. The function of this system is to detect the fire in short stretch of time and cover the area at standard time period, length of time, 10 to 15 minutes, and send a wiring signal to a main server for additional server for further transmission to emergency service. In the instant a fire detected, all of the sensor in the area will become active. As the sensor are developed with little wireless range transmitter, then information will be communicated from one sensor to another sensor until and expect if the sign arrives at the sink. After receiving the data sync, data sync, we'll start processing and check whether the fire positively and represent risks through the estimation of the fire spreading rate. If there is a real danger exists, then the sinks decide the place of the fire. Then at that point, the sink will send a caution message to the local group of firefighters to inform the specific area and regarding the fire and the temperature fire spreading and showing the fire conduct. Next, the local group of firefighters then evaluate the degree and gravity of situation to show up an ideal choice to make an appropriate move at earliest opportunity. If there should be an occurrence of genuine risk, subsequent and preventive action can be initiated to mitigate the situations through appropriate measure before the fire turns uncontrollable. The main aim for this research can simply represent by the following picture. Next, different section of fire are first follows. A finger is a long and narrow extension of the main body of fire. A pocket is an unbound and orientation of the fire parameter surrounded by three sides by fire. An island is an unburned area within a fire which is totally surrounded by burned area. A spot fire is a fire initiated in outer region of the main fire by a fire band. Next topic, and fire detection and decision making. The increased demand of sensor to indicate and monitor the fire behavior has enriched the application of new technologies in the fire field. Sensors are able to sense the certain dynamic and static variables such as humidity, the type of fuel, slope of the land, the direction and the speed of the wind, smoke, etc. And they allow us to determine the direction and possible evolution of the flame front. One of the popular wireless technologies is Zigbee, which is a new industrial standard based IEEE 802.15.4 radio specification and works in an unlicensed band including 2.4 GHz, 900 MHz, and 868 MHz. The technology mainly emphasizes low-cost battery-powered application and smaller solar panels, and is suited for a low data rate and small range communication. Zigbee control has the ability to support mesh networking in which nodes are interconnected with other nodes so that multiple pathway connect each node. Connection between nodes are dynamically modified and updated and optimized through smart built-in mesh routing table. Wireless sensor networks have gone through rapid developments in many applications. This type of technology has the potential to be applied almost every year, hence the research interest in senior network is become higher and higher every year. Next topic, sensor network for fire detection. In this diagram, the component of WSN are nodes, cluster head, gateway, host computer, satellite network. Nodes are connected to gateway through a cluster head, and these are again connect with host computer via gateway, and finally all are connected to satellite network to form the WSN. The previous work was fully depended upon image or database such as weather index, fuel index model, gas boards, and intelligence sensor to make the decision. In this paperwork, all nodes belong to known location and nodes only use temperature sensor, and they are programmed based on a certain threshold temperature. Above it, node will send an alarm signal to the sink. This concept which is solely depends on the node behavior to alert of crisis procedure using simple node component. These provide a detection and information on whether this is a harmless fire or the beginning of wildfire. The key in this method is to make decision by tracking the fire propagation and check the logic behind it, rather than using a complicated database or imaging technologies. The most convenient solution is to monitor forest by using a GUI to represent the event and alerting signal on the monitoring screen using some logical evolution to reach a decision as following figure 4. Once on the nodes detect the fire, all nodes in range of plus minus 45 degrees wake up and start working as a router and sensor. If they can do any sensing at the stage every minute to track the fire spreading. These are the flowchart of fire direction method. Let me conclude the presentation. Conclusion of the presentation. A property of an advanced forest fire detection system that has been proposed to overcome the demerits of existing technology of forest fire detection. It can be ensured that the system can be implemented on a large scale due to its promising result. The system can also improve to upgrade with low power elements and solar power for effective application. These are the references. Thank you.
Thank you so much, Shantan, for your wonderful presentation. Let's see if anyone's have any question or not. I would request our honorable judge, Professor Dr. Sharma, if he wishes to ask any question, or Professor Karmakar, if you wish to ask any question. Yes,
Yeah.
Professor Dr. Sharma, please.
Yeah, Sayantan, right? Sayantan, there is a simple query. Which area you have focused while detecting this fire? Is it urban area or it is rural area or forest where you are going to install, where you have thought of installing this and detecting the fire? Have you collected any data regarding this, that where the fire happens the most?
All over world, I think mainly is happen in the forest. In all over world.
So you have considered forest fire, right?
Yes, yes.
Okay. And you have somewhere you have used this thing that signals are going to transfer data, the sensors are going to transfer data to another sensor. Does that really happen? Because data transfer happens to the central console from where it is being monitored. So it is not sensor to sensor. It may be sensor to sink, I think.
Yes, yes.
Yeah. Okay, fine. Thank you.
Thank you.
Professor Karmakar, if you have any question?
Yeah, it's okay, fine.
Okay. From audience, do you have any question? Anyone? Professor Gautam Das, our web host, am I missing anyone? Anyone have raised their hand?
No, ma'am.
Okay. Okay. Then I'll be moving towards the next presentation. The next presentation is by Rakesh Boral, and the title of the presentation is Solar Photovoltaic Paint for Future, a technical review, and it is authored by Sneha Sharma and Rakesh Boral. I'd like to request the presenter Rakesh Boral, if you are right here on this platform, please unmute yourself.
Yes, ma'am. Hello.
Yes, yes, we can hear you.
Okay, ma'am. Is it visible, ma'am?
Yes, your screen is visible, but actually yes, it is visible.
Okay. So good afternoon and thank you everyone to attend this conference.
Listen, Rakesh, 1 minute.
Right.
You please full screen your slide. Make your slide full screen.
Okay. Hello.
Yes, yes, you are audible,
Oh, okay,
but
ma'am.
your screen
Is
is
it
not visible.
okay?
I will request Moho madam to kindly confirm that he is facing an issue to present to us.
Yes, probably. And Rakesh, would you want us to play the PPT?
Yes, ma'am. Yes, ma'am.
Okay. Then Gautam
Yeah,
sir, you please
yeah.
run the PPT for him.
Okay.
Okay, please start.
Good afternoon and thank you everyone to attend this conference. Myself Rakesh Boral, student of Elite College of Engineering, where I pursued my BTech degree in electrical engineering. I have always been interested in renewable energy, especially in solar power. While pursuing my degree, I have done my final year project titled as Solar Power DC Motor under the guidance of Professor Senasi Sharma, Assistant Professor of Elite College of Engineering, who also helped me to complete this joint author paper. Thank you, Deep, to accept my paper. So here I am to discuss about the newest technology that could not only be cheap but also be installed almost anywhere. That is the solar panel. So first get to the point, what is solar cell? So it's a device that captures sunlight and converts it to electricity. And for the cells that use for solar paint, the same thing happened, but these cells are much smaller than the conventional solar cells, which are scaling in nanometer. Then it has to be suspended in liquids like ink or paint. For that, it's named as solar paint. Torben Dienke and Professor Cox Kalantar Jade first came up with the idea of solar paint. Next slide, please. So, how they made? Different research groups made their own type of solar cells for their technology. Based on this, the name differed. Like in 2013, the researchers at the University of Buffalo are working on the photovoltaics that use polymers and small molecules that are hydrocarbon based and can be applied in liquid form over the large areas, and they emit organic photovoltaic solar cells. Coming to the next, the University of Toronto in 2014, they experimented with a solar paint made of tiny dots, uses semiconductor crystals and used in PV solar cells as well as LEDs and computers, and they name it colloidal quantum dot solar cells. Next slide. Next slide, please. So, actually, this it's different from my slide. Actually, no. It's not the same. I actually okay. So there is a one of more type of solar cells present here. So first of is the quantum dot solar cells. Quantum dot solar cells is a solar cell design that uses quantum dots as the absorbing photovoltaic material. It attempts to replace the bulk materials such as silicon, copper, indium, gallium selenide, or cadmium telluride. Quantum dots have band gaps that are tunable across a wide range of energy levels by changing their size. In bulk materials, the band gap is fixed by the choice of materials. For this property, quantum dots attractive for multi-junction solar cells, where a variety of materials are used to improve efficiency by harvesting multiple portions of the solar spectrum. As of 2021, efficiency exists 18.1% for the quantum dot solar cell. Next slide, please. So coming to the next type is called perovskite solar cell. A perovskite solar cell is a type of solar cell which includes a perovskite structure compound, most commonly a hybrid organic, inorganic lead or thin halide based material is the light harvesting active layer. Perovskite materials such as methylaminum halides and all inorganic materials are cheap to produce and simple to manufacture. So this paint may be a budget-friendly option for everyone. Next slide. So here is the base research cell efficiency on different generation solar cells, and we are now talking about the third generation. But we can see from the chart that the previous generation cells has more efficiency than this generation, like the crystalline silicon, multi-crystal silicon, etc. And the third generation are the dye-sensitized, organic, perovskite, quantum dots. The last one is the third generation, from the third generation. That's why this technology will take some time to be available commercially. So many research and experiment has to be done to get to the base output. Next output, please. Next slide. Sorry, is Synesis sir present here?
Yes, I think so.
Sir,
Yes.
this
Okay,
is
okay.
not the same.
I will. Okay, okay. I will present the another slide. Okay.
Sneha sir, can you please present if you have?
Okay. Okay.
You have the control, okay? Not a
Okay.
problem.
Okay. 1 second. And slide is present.
As a slide number is
Okay. Okay.
slide number 12, sir.
12. Okay. That's it.
That
is okay. That's slide.
okay. So actually,
Carry on.
Because it's not on that slide. So it's the solar paint hydrogen. So it's one type of solar paint, and it contains newly developed substance called synthetic molybdenum sulfide, absorbing moisture from the air. It works similar to the silica gel. That's we actually see on the packages for consumer products in order to keep them dry. So and also this solar paint contains the titanium oxide, a substance already present in a conventional paint. It helps the paint to use solar energy to break down the absorbed moisture into hydrogen and oxygen particle, and this hydrogen can be used to produce clean energy. Next slide. And this one is called dye-sensitized solar paint. Is this paint type dye-sensitized solars? One type of solar cell generally consists of a dye-attached semiconducting electrode, a metallic electrode, and an electrolyte. This DSC or dye-sensitized solar paint powers through an excitation of electrons in the dyes and the oxidation reduction reaction between the dyes and the electrolyte. They are carbon nanotubes as paint materials because they have both semiconducting and metallic properties. Next slide. Here is the organic cells. Sorry, ma'am. This actually this photo is not visible to the mobile, so it's not upload on the mobile. If we actually present it to the desktop, it can be visible. So we are talking about the organic cell. So we already talking about this type of cell already. This organic cell made up of plastic solar cell or this type of photovoltaic use organic electronics, a branch of electronics that deals with conductive organic polymers or small organic molecules for light absorption and change transport of produced electricity from sunlight by the photovoltaic effect. Next slide. And here is the last one, the nano ink solar paint. August 12, 2013, a research team from University of Toronto and King Abdullah University of Science and Technology used colloidal lead sulfide quantum dots that can be used to harvest electricity from the entire solar spectrum, because their energy level can be tuned by simply changing the size of the particles. So this type actually derived from the quantum dot solar cells. Next slide. Next. So here's the comparison between the conventional solar cells and the solar made from the solar paint. When talking about the one conventional solar panel, it's not so heavy, but a house depending on the solar power need more than 20 cells or above solar panels, and then when it become heavy. On the other hand, the cells used in solar paint not even visible and be painted like other normal paints, so its weight does not vary. The second point, the wavelength of the visible light occur between 400 nanometer to 700 nanometer. The bandwidth of the silicon solar cell or conventional solar cell is very near to the infrared range. Any radiation with the longer wavelength, such as microwaves or radio waves, lacks the energy to produce electricity from the solar cell. On the other hand, the cells used in solar paint made of substance which are also work on longer wavelength. That's why it can even respond in low light. The last one, most of the conventional solar cells are based on the silicon or other costly metals or substances. But for the solar paint cells that are made of components that are very cheap, that we already talk about the perovskite cells. Okay, the next slide. Okay. So the challenges. So this technology also facing some challenges like other early technologies. Like the materials in this type of sources are good in low light levels, but in addition, it's not work good as conventional solar cells in high intensity light level. So researchers find a way to make work in good conditions equally, so the output can be double. Overall, it's a paint and can be painted on the wall, on wall or roof, but researchers find a way so that it not gets serious damage from the rain or other natural calamity, as well as who can paint can also install it alone. Of course, an engineer must be needed to put all the things together, but not like the whole team working on your house all the day long, like the solar panel installation. And the last one, the researchers find the right material or materials to get the best output. And it is the biggest challenge for it. Next slide. The solar here the advantages of the solar paint. So the solar paint hydrogen can absorb water vapor and split into the generate hydrogen, and making it one of the most cleanest source of energy. It doesn't need any water reservoir, just need the moisture from the air. It doesn't even make any ozone depleting substance, so we can say that it ozone and environmental friendly, and we need that actually. And we all know that how much this solar companies take action quickly. So the more hands means the progress is faster, and we can hope that it will be available commercially soon. Next slide. So the future applications. If you have a pre-existing solar setup, this technology then work as a great way to enhance existing solar setups. People with solar panels installed create additional energy source by painting their roofs and walls with the solar paint. We have electrical vehicles now, but in future, maybe with help of this technology, we can get our first solar vehicle. And if somehow we can able to increase the efficiency, almost every house and companies can use it as a primary. Next slide. So coming to the conclusion, this technology of any kind could make it solar power system found everywhere around the world. Every roof has its potential to be solar painted, but a lot of work needs to be done before use it commercially. Until then, if you want to saving some money on electricity bills, you can you want to generate your own energy. Rooftop solar panels are the only option without a doubt. But it's not only in here. If you have a system installed before December 31, 2019, you are eligible to 30% tax credit. Means 30% of your tax will be refunded. And if it's between the 2020 to 2022, it gives you the 26% and 23% until the 2023. Next slide. So this was accessory. So here is all the list papers I getting help from, and thank you all the authors to make it simple and understandable to everyone. My presentation ends here. If anyone has any question regarding this, you can ask me. Thank you.
Okay, thank you so much, Rakesh. It was an excellent presentation. I would like to request the audience, if you have any question, you please raise your hand.
Yeah,
Okay.
madam, I would like to ask
yes
a question.
Yes, sir, please.
Yeah, Rakesh, right?
Yes, sir.
Yeah, Rakesh, this solar paint you are talking about, is it applicable to any surface, or it requires some pre-surfacing of the object?
No, sir. It can be installed in any surface. If
okay.
It's exists or not already.
Okay, right. And you have touched upon this futuristic technology. You could have gone much deeper into it. Yeah.
Yes, sir.
Okay.
Yes.
Thank you.
Rakesh.
Thanks.
Hello. Yeah. Rakesh,
Yes,
in your paper and in your presentation, you have already shown the research cell efficiencies of different generation solar cell, where you have shown the
yes, sir.
First generation crystalline silicon have efficiencies 26.7%, and third generation quantum dot sensitized, actually the paint, solar paint, right? Efficiency is 9.56%. So if the quantum dot sensitized efficiency is less than the crystalline silicon or polycrystalline or monocrystalline, then why we use this type of paint in future? Hello? Do you understand?
Can you ask this again?
Actually, you have shown already in your paper and presentation the quantum dot sensitized, actually the paint, solar paint, the efficiency is 9.56%, which is lesser than the monocrystalline or polycrystalline cell, right?
Yes, sir.
So why we used this type of paint in near future?
Actually, sir, it's in the testing phase. It's not. It's in the testing phase. So actually, it has to exist the 10% minimum. So it's in the testing phase, and in future, it's has. We can hope that it can exist the our requirement.
In future, you hope that the efficiency will be increased. Right?
It's just tries that very hard.
So, okay. And what is the cost effectiveness as compared with the crystalline and monocrystalline or polycrystalline cell?
It's sir, a fraction, sir. The existing solar cell fraction, only fraction cost.
Okay. Thank you.
Okay, thank you so much, sir. Audience, I think Deeposri ma'am raised her hand. Yes,
Yes,
Deeposri ma'am, please.
Yes, I have one question or curiosity that this solar paint is not readily available in market now. It is under
No,
R&D
no.
process. But right? Am I right?
Yes, ma'am. It's not commercially available now.
Do you have any idea or any data what will be the pricing of this solar paint per liter? Do you have any idea or any information?
No, ma'am. It's I do not have any idea about the liter per liter.
Actually, already judges have asked that the efficiency is getting reduced day by day. So why it is so? I mean, the research should be in this way that efficiency must be increased. But
Yes, ma'am.
why the
Yes, ma'am.
efficiency is getting decreased? This is quite, unnatural.
Yes, unnatural, ma'am. Because the is just is not so much time that this paint actually invented. So the researchers try their best to increase the efficiency of this technology, and the problem is that the existing PV solar cells, they are actually from the long time in the market or in commercially available. So it's going through all the process, but it's still in the testing phase. So it takes some time.
Usually, efficiency increases day by day after research work, but in this case, it is not.
It will. It's not actually, ma'am, but
okay.
Okay, thank you, Deeposri ma'am. I think I should move to Shorodip sir. Shorodip sir has raised the hand.
Okay.
Yes, thanks. Thank you, Rakesh, and thank you, Sneha sir, for this good presentation and good proposal. So I have a little question. So to Rakesh, that
Yes,
I have gone through your PPT. I have not seen your full paper. I have gone through your PPT, and my question is from a common man point of view, that if though it is a proposal, it's not it means it is not in market, it's not been fully implemented. Still, I have a question from a point of common people point of view, from a common people, that if it will be commercially available in market and it will be full phase implemented, then how much cost will be, means how much cost effective it will be, and what should be the longevity of this type of solar cell of this type of
last maximum of 15 years. One installed.
Last maximum?
Yes, 15 years on installed. It can be last up to 15 years.
And means within 15 years, there will be no need for any maintenance or any for only. Yes. Tell me.
No need for any other extra cost. And the cost will be the fraction. Means, and if we now want to install a solar panel in our house, so the cost will be fraction for this technology, for this solar paint.
And there is no need to maintain yearly or anything like that. We have to just change it after 15 years.
After 15 years.
And in your literature survey, so any country of any region of this world, current world, any there is implemented anywhere, means is there implementation is there?
Actually, as I said already, it's not actually commercially available, but it actually it is actually on the universities actually researches it. So it's not
so it's in experimental phase.
Experimental phase is still in the experiment phase.
Okay. Thank you, Rakesh.
Okay, thank you, Shorodip sir. And once again, I must thank Rakesh Bodal for patiently answering all these questions.
Thank you,
So, yes, thank you. I'll be going to the last paper of this session. And the title of this paper is Solar Powered Water Quality Monitoring System using ZigBee by Sneha Sharma and Abhijit Sarkar. I think Abhijit is the presenter. And Abhijit, have you joined right here?
Yes, ma'am. Yes, ma'am.
Okay, okay, okay. So you can start your presentation right now.
Okay, okay, ma'am. Hello, everyone. Hello, everyone. I am thankful EC Principal, honorable guest, and host of this session for inviting me. I am Abhijit Sarkar, completed my BTech from Elite College of Engineering in 2020.
Abhijit, please make it full screen.
Okay, ma'am. Okay. Okay, 1 second. Yes. Hello, everyone. I am thankful EC Principal.
No, it is not yet full screen. Okay, you just press either F5 or
Yes, ma'am.
or presentation, starting
Okay, okay.
presentation.
Yes, ma'am.
Abhijit, should we? Yes, it's okay now.
Okay. Hello, everyone. I am thankful EC Principal, honorable guest of this session and host of this session for inviting me. I am Abhijit Sarkar, completed my BTech from Elite College of Engineering in 2020. I am completed Internet of Things course from IIT Kharagpur. I am very interested in new technologies, IoT, cloud computing, AI, and machine learning. I am a founder of Moftonis Technologies. Currently, our company provides cloud computing, Android app solution, and many more things. I am published a paper in STEM 2020, which is organized by Maulana Abul Kalam Azad University of Technology. The paper name is Solar Power DC Water Pumping System. So today I am presenting jointly authored paper in 2022. The paper is Solar Power Water Quality Monitoring System using ZigBee, authored by Sneha Sharma, Assistant Professor, Elite College of Engineering, and Abhijit Sarkar, student of Elite College of Engineering. So it is a water quality monitoring system which is work using ZigBee. It is a wireless sensor network module, and it is also has different modules like Arduino, turbidity sensor, PS sensor, and it is powered by solar. These systems can be easily installed in remote location, and anyone can monitor water quality via remotely using this system. This system has different modules which is enable this system work perfectly. We are using solar power because in the remote location, unavailability of power source, we need to monitor water quality 24/7. This is why we are using solar panel and battery for power source. We are using ZigBee for wireless sensor network module for transmitting and receiving water quality data. This is a sensor networking module, delivers low latency communication, and it is a chip typically integrated with radios with the microcontroller. We are using a Arduino microcontroller. It is a 14 input output pin. It is a 16 megahertz microcontroller. It has a USB connection, power jack, and a ICSP header and reset button. We are using turbidity sensor. It is a sensor for checking the water increases and level and cloudiness and haziness of the water. We are using pH sensor for checking the water alkalinity and acidity in the water. We are using turbidity sensor in the river, cloud river, and checking the haziness and cloudiness of the water, and it is suitable for drinking and the agricultural use purposes, which is used for checking the water quality. Is there some microparticles or any microbes, viruses it has? So we are using turbidity sensor for checking this. This is a block diagram of wireless sensor network at remote location site. In the center there is a microcontroller, Arduino microcontroller. In the left side there is a input section. In the input section there is a temperature sensor, pH sensor, conductivity sensor, turbidity sensor, and all the sensor connected in the input section. In the right section there is the output, and we have a solar power battery in power source. So in the output section there is a ZigBee. It is send all the data, collected sensor data in the base station. This is the block diagram of transmitter and receiver. In the transmitter section, we use the Arduino microcontroller using solar power, and there is the input section is lots of sensor, pH sensor, level sensor, turbidity sensor, and all the data collected to the sensor and sent to the ZigBee network, ZigBee module. In the receiving section, we are using computer and MATLAB, and all the data collected to the ZigBee, and we see all the data in PC. This is the schematic diagram for Atmega 328P. It is our blueprint of this project. We made this project through this. This is a flow chart for general water flow of water quality monitoring system. When we start this system, all the sensor collected data and it is sent to the microcontroller. Microcontroller will show the data in LCD and it is sent to the ZigBee. ZigBee transmit to the data at the base station, and base station there is also a ZigBee and it is sent to the PC. And computer is data, the process the data, and hyper terminal and the Visual Basics section there is all the data in a text format with all the data in TimeLab format, and all the data text format we read in the MATLAB, and all the data you observe and comparative all the in graph format, so analyze the which water quality levels, and it is we can use this system. So advantage of this system, advantage of the system is we measure the pH level, oxygen level, and water level, and utilizing sensor at the area. This system is using solar power, so it can be easy to use in the remote location. This system collect data and send it to the remote location to base location in a real time. Our country has lots of rivers. This system helps to mapping a river water quality from starting to end point of the river. Our country has a lots of river, Ganga, Yamuna, Brahmaputra. This system helps the quality of the water and check the today's pollution level. It is easy to use and mapping, also mapping all the rivers data water quality. In our country, our farmers are using river water for their agricultural purpose. So this system can help to monitor the water quality via solar power. So in the conclusion, our proposed model of solar power water monitoring system using ZigBee based on ZigBee water quality monitoring system that provide minimal power consumption with high quality is presented. And in future, we are also planning to upgrade ZigBee to IoT-based cloud system, and it is also cloud system, cloud computing, and build a mobile app for this system. and it is also help to use in large scale, and large data can be handled this system. So this is our proposed model, and this is the reference which helped me to complete this project. And thank you everyone. If you have any question, you can ask me. Thank you.
Thank you so much, Abhijit. Let's see if anyone wishes to ask any question.
Hello.
Yes,
Abhijit,
sir.
Yes, sir.
Have you used any simulation software like a MATLAB?
Yes, sir. MATLAB.
What is the any result output from the MATLAB?
No, sir. We are proposed this model, and we are not actually made this. We have proposed this model.
Okay. What is the actual application?
This system helps the water quality level and the acidity and alkalinity of the level and cloudiness and haziness of the water. So easily check the water quality from the system.
Oh, thank you.
Okay. I would request Dr. Ashwini Sharma, sir, if you wishes to ask any question.
Yeah, Abhijit.
Yes, sir.
You are right now. You are done with your masters, or you are doing it?
I am not doing my masters right now. I am completed my BTech and currently work my component.
Okay, okay. So I was just thinking, why can't you make it? Means, what will be the cost of making this thing?
So we are now currently propose this model, and we are, if we have get enough funding, we can easily make this possible, and we can make it.
That's what I'm asking. How much fund is needed for this?
This system it is also 10,000 to 20,000 almost for one sample model. It's initial.
Yeah, but then I was thinking on the same line, if you could have come up with this practical model of it.
Yes, sir.
See, nobody is going to give fund for this. Nobody is going to fund it for you unless you fund it for yourself. And then you go and ask for the funds. The idea is very good, but going it theoretically, that will not serve the purpose. Have you seen this kind of model somewhere?
No.
That's what I'm saying, that if you are able to make it, 10,000, 20,000 is not a big money right now. But yes, you can get a very good funding out of it later on. You know what kind of condition is happening with the river Ganga, and there are so many other places.
Many pollutions.
Yeah. Okay. Thank you.
Thank you so much, sir. From audience, any question? Okay, Deepasree ma'am, please.
Actually, I have some generic question. What is the efficiency of this system? And one more question: is this available in other countries? Or
Like this system is approximately the quality and of the sensor. The quality of the sensor, if you use high quality sensor, that is accurate, and it also gives 80 to 90% accurate data. If we use cheap quality sensors, it different from that. We get also 60 to 70% accuracy. And in the foreign country, it is available. In US and Australia, there is using this system for their water quality checking. Monitoring.
okay, thank you.
Okay, thank you so much. Abhijit, please mute yourself.
Okay.
Anybody has any more question? Okay. Then Abhijit, thank you once again that you have wonderfully handled everyone's query. Now I have almost come to the end of the session, and I would request our session chair, Professor Dr. Shubhashish Banerjee, to wrap up the session with just summing up all the presentations of this session.
Thank you, Moa. Actually, now total 6 presentations were there, out of which only 5 have been given, isn't it?
Yes, yes, sir, absolutely so.
One has not been given.
Yes, sir.
Anyway, so from chronologically, I must say, first 2 presentations was from our faculty members. One is Professor Abhijit Chakraborty and another is from my ex-colleague Bonani Ghosh. So as they are all mature people, their presentations was definitely very good and they answered all the queries also, right? So I have nothing much to say about them. I'm very happy to see that you have students' participation also, and students' quality of presentation cannot be as good as our faculty members, so that is accepted. But I have some questions, rather I have some queries, one by one I'm asking. That WSN-based forest fire detection system, it was presented by Shayantan Basu, right?
Yes, sir.
Actually, tell me, is there any backup system for this? Because you are finally going to protect the nature. If your system fails, do you have any backup? Just like our electrical engineering, we go for primary protection, secondary protection, something like that. Do you have any backup for this?
Shayantan, are you present right here? Otherwise, I would request Deeposri ma'am to answer the question.
Yes, yes. Actually, sir, so far I know, as per my, information or my knowledge, there must be some backup system. But what kind of backup system right now, I am not able to answer that.
You're not very sure about it, isn't it?
Yes, yes, sir. Yes, sir.
And secondly,
there must be some backup system. Otherwise, this system is, this is not very recent technology. WSN based is recent, but the forest fire detection part is, it is some old system. It already has been used earlier.
This is an old phenomenon, but we just wanted to know whether my protection system fails by any chance. Is there any backup for that? And what is the cost of that? So there should be something mentioned in the paper regarding that. May not be everything is readily available now, but this should be looked into.
Yes,
otherwise it was good. Okay.
Okay, sir. Okay, sir.
And then was solar photovoltaic paint. Again, the same question is coming in my mind also. What is the cost part? And what is the longevity? He said it can be painted for after 15 years or so. These are all exterior paints. Under any weather condition, it can be used for 15 years. I don't think so.
Rakesh, are you there?
Yes, ma'am.
Okay, please answer the question.
You have said this is definitely for exterior painting. Otherwise, it cannot be a solar system. You said roughly 15 years of life. But is it under any weather condition? And any adverse weather condition? I don't think so. Do you have any idea about it? Anyway, please I do not want to embarrass somebody. As a student, you are definitely doing a very good work, and for which we should be very proud. And Elite College of Engineering is encouraging these sort of things. I really like it. But please keep these things also in your paper. At least it should be reflected somewhere. And third, that ZUB.
Sir, co-author Snehesh Sharma sir is already there. He is also present right here. So if Snehesh Sharma sir
he can say something, yes.
Yes, sir. Yes, sir. Actually, this type of paints is a recent technology, sir. But actually weather condition, if you consider weather condition, different type of weather condition we can consider in a climate with respect to different type of climate in a desert climate, in case of desert or in case of our hill area, so that with respect to this condition it can be tolerate, it can be plus minus 10 to 20% heaviness will be present.
Oh, this
so that
figure 15 years.
no, not 15 years is exactly figure, sir. This can be plus minus 10% tolerance, under 10% tolerance.
You see, nowadays there is a total climatic change. Yeah? We are
Yes,
having
sir.
this
Yes, sir.
Amphan and all that things is
Yes,
coming
sir.
all over the globe. So
Yes.
under this adverse condition, how long it can be used, or what is the length of the longevity of this sort of paint?
Actually, in case of our country, with respect to our country, this climate change is totally different with respect to another country, because here also we can see that 6 months is summer, 6 months is winter, and 3 months is winter and 3 months is rainy season. So that our condition with respect to this paint is very hard. This is a very critical condition, but with respect to constant fixed weather, just like that winter in 9 months for winter or 9 months is summer, then we can conclude a particular time period. Okay, sir. But in case of our condition, because of our country or our state, with respect to our state, we can see that there is a different type of time period with respect to solar paint. So that 15 years
What I
is
mean
not.
to say that it with the when a worst type of weather condition, it can be used for a longer time or not. Otherwise, it will not be commercially viable.
You can sir ask me that which condition or which weather will be suited for this paint. Am I right, sir?
Otherwise, you have to mention that these sort of paints can be
Obviously,
in only
sir.
this sort of weather condition.
Obviously, sir, because of the solar paint, whenever in our country, if any paint we use in our any weather condition, different type of weather condition, the longevity will be different. So that
that
obviously
sort of statement should be available in the paper. What I mean to say.
Yes, sir. Yes, sir.
Right?
Yes, sir.
Okay. Thank you. And the last presentation, that solar power water quality monitoring. So in this case, I would like to know, we have hard water, soft water, there are different type of category of water. Even we have something as drinking water also. Is it applicable for all these things?
Yes, sir.
Drinking water from this?
Yes, sir. We are using turbidity sensor for checking the water cloudiness and haziness, and we are also using pH sensor, the acidity and alkalinity of the system.
Okay.
So we can easily check the drinkable for checking the water, drinkable quality.
How it is suitable for coastal areas where we have saline water?
Yes, sir. So we can use our system. It has a level sensor and it is also a turbidity sensor. So we can check the level and quality of this water, so it is suitable for drinkable or not. So if it is not drinkable, so we cannot use for our drinking and other uses.
Can it be used in industry where soft water is required? Because in many chemical industries, we use water softener plant, water treatment plant rather.
Yes, sir. It can be used. Yeah, it can be used.
Now, this sort of information should be available in your paper. What I mean to say.
No, sir. We are using this is the mainly civil people are using the water quality, and we are also using Zigbee base. So it is.
That means it can be used only for construction work, nowhere else.
No, sir. It is our proposed model is using this system. It has a microcontroller and it is also collect data from all the sensor, and it tells that it is suitable for not. It has a graphing module and it is check the quality, and we use for this for our industries or agriculture or drinking purpose.
That means it is multi-purpose. What you mean to say?
Yes, sir. It is. check all the minerals and quality and pH level, acidity, alkalinity. All the system are collected from different sensor. We all get all the data in visual form.
Okay. And what will be the price for them, and what should be the cost portion?
This system around, if you is small scale, it around 15 to 20,000 approx. The main price is costing solar panel and the battery. This is the main costing, and we are
look. This is a very vague statement. 15 to 20,000 is not the should not be the specification. 15 to 20,000. If I spend, how much quantity of treated water I will be getting? You tell me in terms of that.
Yes. So if we invest in low scale, we get also 100 to 500 liter water treatment
per day.
Per day.
Anyway, otherwise presentation was okay, but we had some little bit questions, because whatever you produce, it has to be sellable. It should be under commercial production. Unless and until it is economically viable, you cannot market in the market. And what Professor Sharma has correctly pointed out, that is, nobody is going to finance you. Nobody will call that I am going to finance you. You have to make a prototype. You have to go to people and you have to sell your product. The way you can sell your product, before selling your product, you have to go for a prototype. For that, you have to go for investment.
Yes, sir. Yes.
Okay. Thank you.
Thank you, sir.
Okay. Deepostri. Deepostri,
Yes,
ma'am, would you? Yes.
Yes. If sir allows me to add some information to the question that he asked me.
Sure.
I think, sir, I was thinking about that. Actually, the backup system may be consisted of microcontroller, that is PEEK or Atmega, that are already available in the market. I mean, these technologies already running from few years ago. Okay. So that microcontroller based forest fire detection system may be the backup system of this WSN based forest fire system.
Okay.
Forest fire detection system. Maybe.
Okay. Anyway, thank you everybody for attending the session patiently, and to the presenters also. They have also performed very good. They have answered all the questions, whatever has been asked, rather in a very decent way. Thanks, and I'm really very proud to see that student paper presenters are also here.
Yes, sir.
Faculty members, they are all mature people, so they can do it. But student paper presentation is very important, because this sort of culture should be grown up from the college level itself.
Yes, sir. That's true.
Thank you.
Okay. Thank you so much. Thank you, the honorable judges. Thank you, our honorable session chair. And thank you, audience, for your patient hearing. But I'm not going to announce the end here, because today we have a special attraction, you can say, just only to reduce your monotony a bit, only to reduce your stress a bit. We are coming back again at 6 p.m. with our cultural program, that is Elite Moments. So please stay with us. Please join again at 6 p.m. Until then, I, the moderator, Mohua Datta, signing off with the web host, Professor Gautam Das. Till then, goodbye. But please don't forget to join at 6 p.m. today. Thank you so much.
Thank you.